This is the Chapter 12 test review. I'm going to start with the problems that are actually on the review. They model the problems in the short answer portion of the test, and then I will do some additional problems that model some of the problems you'll see on the multiple choice. So number 1 says use the binomial theorem or Pascal's triangle to expand 1 over x minus the square root of x to the 5th. I just use Pascal's triangle. So if you want to raise it to the 5th power, the first thing I got to figure out are what are the coefficients in the 5th row of Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. This is the 5th row of Pascal's triangle. Remember that the way that this works is the first term in the binomial starts with the largest power and decreases by 1 each next term. The second term in the binomial starts with an exponent of 0 and works its way up, so that the last term in this expansion should have the square root of x to the 5th. So I'm going to start by doing this. 1, 5, 10, 10, 5, 1. And then I'm going to start with the first term, 1 over x. So it should be 1 over x to the 5th, 1 over x to the 4th, 1 over x to the 3rd, 1 over x squared, 1 over x to the 1st, and the last term, no 1 over x, because it's 1 over x to the 0 power, which is 1. The second term, be careful, it's negative square root of x. So the first term should have no negative square root of x, because it's negative square root of x to the 0 power. The second one should have negative square root of x to the 1st, negative square root of x to the 2nd, negative square root of x to the 3rd, negative square root of x to the 4th, and negative square root of x to the 5th. And all of these have plus signs between them right now. However, they're going to alternate signs here in a minute, since the second term was negative, and anytime you raise a negative to an odd power, you get a negative. Okay, so if you can get this far on the test, I'm going to give you 2 out of 4 points, because at least you got it plugged in, and plugged in correctly. The next thing I'm going to work on is simplifying. Okay, so this 1 times 1 over x to the 5th power is 1 over x to the 5th. Well, remember 1 to the 5th is 1, so I just leave the numerator as 1, and I put the x to the 5th in the bottom. Plus, alright, here's the fun part. Actually, I should say not plus, and the reason it's going to be minus is because you're multiplying times negative square root of x. So it's going to be, I'm going to write this as 5, and it's going to be 5 times 1 over x to the 4th times negative square root of x. So really it's just negative 5 square root of x over x to the 4th. The next one is going to be 10 times 1 over x to the 3rd times positive x. So it's going to be plus 10x over x to the 3rd, but that's going to simplify more. We'll talk about that in a minute. The next multiplication, 10 times 1 over x squared times negative, well, what's negative square root of x to the 3rd power? Well, when you do this, these two multiply together to give you x, so it's going to be times negative x square root of x. So it's going to be negative 10x square root of x over x squared. The next one's going to be 5 times 1 over x times x squared. Remember, it's going to be positive. And when you multiply 4 of these out, I will just do 2. Negative square root of x times negative square root of x is x. So if you have 4 of them, that's x times x. So it's going to be plus 5x squared over x. And the last term, since there are 5 of these, it's going to be negative this is x, and this is x, so it's x squared times negative square root of x. So it's going to be negative x squared over, or sorry, negative x squared square root of x over nothing, because there was no denominator here. If you can get this far in this problem, I'd give you 3 out of 4 points. It wouldn't be 4 out of 4 because you would have to do any simplifying of fractions, like the third term is really 10 over x squared. The fourth term is really 10 the square root of x over x. The next term is 5x, and then those are the only fractions that could actually be simplified. So this would be the final answer. Problem 2. A ball is dropped from a height of 80 feet. And then it bounces. The elasticity is such that it rebounds 3/4 of the distance it has fallen. So 3/4 of the distance, or 80 times 3/4, is going to be 60 feet. And that's on bounce 1. And then on the next bounce, which is bounce 2, 3/4 of the previous answer is 45. And then on the third bounce, 3/4 of the previous answer is 33.75. And this pattern continues. We want to determine how high the ball bounces on its rebound on the 6th bounce, and find a formula for how high the ball rebounds on the nth bounce. So one way of doing this is actually to just continue the pattern. If you want to keep multiplying the previous answer by 3/4, you're eventually going to find out what you get on the 6th bounce. Another way of doing it is to first find the formula for the nth bounce, and then you could actually plug in 6 for n. Since each previous term is being multiplied by 3/4, that means that this is a geometric sequence whose common ratio is 3/4. Now the initial value of this problem is actually 80, but usually we talk about problems where n is 1, and on the first bounce it was at 60 feet. So I'm going to give you 2 ways of looking at this problem. One way of looking at this problem is to say that the first term is really 60 because that's when n is 1. The formula for a geometric series is a sub 1 times r to the n minus 1. So the nth bounce would be 60 times 3/4 to the n minus 1. And now when you want to find out how high it bounced on the 6th bounce, you find the 6th bounce by doing 60 times 3/4 to the 6 minus 1 power, which is approximately 14.24 feet. Well, there's another way of doing this, using 80 as the initial value. But if I use 80 as the initial value, remember that's not when n is 1. So another way of writing this problem is to write it as 80 times 3/4 to just the n power. The reason I didn't put the minus 1 is because really this is like term 0. And if you use this formula and you do 80 times 3/4 to the 6th power, you'll find out the answer is 14.24 feet. Problem number 3. What values of x make the following expression arithmetic and geometric? Let's start with arithmetic. When a sequence is arithmetic, the common difference is found by subtracting the second term minus the first term, or it could be the third term minus the second term, or it can be the fourth term minus the third term. We're going to use that concept to create an equation to solve for x. Well, I'll do the second term minus the first term is going to equal the third term minus the second term. This is an algebraic equation I know how to solve. So I get x minus 5 minus 1 is equal to x plus 1 minus x plus 5. So x minus 6 is equal to 6, or x is equal to 12. So if x is 12, this particular sequence would be arithmetic. Now let's talk about how this particular sequence could be geometric. Remember, it's geometric if the common ratios are all the same, and the common ratios are found by either taking the second term and dividing it by the first term, or the third term divided by the second term. So we're going to use this equation to solve a proportion to find x if this were geometric. So I'm going to do the second term divided by the first term must be equal to the third term divided by the second term. You solve proportions by cross multiplying. So I'm going to skip steps. X minus 5 times x minus 5 is x squared minus 10x plus 25. And then 1 times x plus 1 is x plus 1. This is a quadratic equation, so in order to solve it, I'm going to set it equal to 0. For this particular case, I claim that this particular trinomial is easy to factor. The two numbers that multiply to give you 24, but add to give you negative 11 are negative 8 and negative 3. So x must equal 8 and 3. Either of those numbers, if plugged into that sequence, will make this a geometric sequence. In number 4, I want to express this sequence, this series, I should say, using sigma notation. Well, in order to do that, the first thing I want you to notice is what kind of series it is. You'll notice real fast it's arithmetic. So if it's arithmetic, I can use this formula to find the equation that best represents it. So the nth term is the first term plus n minus 1 times the common difference, which is d. And that's 3. And then I would simplify, so I get 3 plus 3n minus 3, which is going to equal 3n. So the expression is 3n. So sigma notation, 3n, we always start with n is 1. Wait a second, what number goes on top of sigma? Well, in order to figure that out, I need to figure out what term 99 is. So 99 is equal to the first term plus n minus 1 times the common difference. We're going to solve that equation for n. So 99 is equal to 3 plus 3n minus 3. The 3's cancel, so 99 is equal to 3n, so n must equal 33. So now I can come back down here, and I know in order to find the sum of that particular sequence, I would go from n equals 1 to 33 and use the expression 3n. In order to write a repeating decimal as a fraction, we use our formula for the infinite geometric series, which is a sub 1 divided by 1 minus r. And the algebra behind this problem was kind of daunting. Like, you had to start with the first part that wasn't the repeating part, 211 divided by 100. The reason it's divided by 100 is because this is in the 100th place. And then the rest of the sequence, the important part, would be 25 over 10,000 would be the first denominator, because this number is in the 10,000th place, plus 25 over, then you tack on 2 more zeros, and the reason you tack on 2 zeros is because the repeating pattern has 2 numbers, so you start with the 4 zeros from the first fraction and then tack on 2 more, and then the next one, let's see, I have 6 zeros, 3, 4, 5, 6, and you would tack on 2 more, and you'd continue that. The first term would be this. The common ratio would be the second term, which is 25 over a million, divided by 25 divided by 10,000. And you would end up getting r is equal to 1 over 100. That's the common ratio. So the sum of just the repeating part is the first term, 25 over 10,000, divided by 1 minus 1 over 100. And you can just put this in your calculator as long as you're using parentheses in the right place. And once you get that answer, you would have to add back to it the 211 over 100 to get the fraction that represents that repeating decimal. But we found out in class that there was a much easier way of doing this. If you type into your calculator 2.11252525, and you keep doing this to at least, fill up one line on your screen of the calculator, and then press math, enter, enter, it'll just give you the fraction much faster. In number 6, we want to find the sum of the arithmetic series in which the first term is 55, the common difference is 12, and we want to add the first 10 numbers. So in order to do this problem, the formula for the sum was n over 2 times a sub 1 plus n minus 1 times d. So n is 10, 2 times the first term, plus 10 minus 1 times 12. What I would do is I would first evaluate this part in my calculator. 2 times 55 plus 9 times 12 is going to be 218. And then 218 times 5 is 1090. And that's the sum of the first 10 terms, whose first term is 55, and the common difference is 12. Not all sequences are arithmetic or geometric, and sometimes they can be kind of tricky to find. So in problem 7a, I want you to notice it's not arithmetic because you can't add a number to get the next number. And it's not geometric because 26 divided by 6 is not equal to 126 divided by 26. So although this is neither, it doesn't mean that I can't find an expression for a sub n. This is what I want you to see. These numbers I wrote above those numbers are all powers of 5. If you add 1 to each of those powers of 5, you get your terms in the sequence. So if you do 5 to the first power and add 1, you get 6. If you do 5 to the second power and add 1, you get 26. If you do 5 to the third power plus 1, you get 126. So a sub n is 5 to the n power plus 1. But that kind of takes some getting used to. You have to practice trying to look for these kind of strange patterns. But before I decide that a pattern is neither, I'm going to check the other two. So in part B, I'm going to first check and see if it's arithmetic. I'm always going to check arithmetic first. Well, it looks like it goes up 0.5, up 0.5. Yeah, it's arithmetic. If arithmetic didn't work, I would have tried geometric next before I went on to neither. So this is arithmetic. How do I find a sub n? Well, a sub n is equal to a sub 1 plus n minus 1 times the common difference. And then I'm going to simplify this. So I get 0.5n minus 0.5. That's going to be 4.5 plus 0.5n. In number 8, I want to use sigma notation to write 1 plus 5 plus 9 plus ... plus 77. And the first thing I'm going to try to do is I'm going to try to figure out, is this arithmetic or geometric? For this particular problem, it's going to be one or the other. Well, it looks like it's going up 4 each time, so let's go with arithmetic. So if it's arithmetic, I need to first find the expression to represent the nth term, so I can write it next to sigma. So a sub n is equal to the first term plus n minus 1 times the common difference, which we just found out is 4. 1 plus 4n minus 4 is 4n minus 3. So sigma 4n minus 3, and we're going to start with n as 1, but what goes in the top of the sigma? Well, I need to figure out what term of the sequence 77 is. So 77 is equal to the first term plus n minus 1 times the common difference, which we just found out was 4. And now I'm going to solve that equation for n. So 77 is equal to 1 plus 4n minus 4. 77 is equal to 4n minus 3. 80 is equal to 4n, so n must equal 20. And there we go. Remember, when you're finding n better be an integer. If it's not, something went wrong. The last problem on the review sheet says, what is the present value of an annuity that consists of 30 payments of $300 at an interest rate of 8% per year compounded monthly? Well, we used this formula when we introduced this, but then we also showed you how to do this on the calculator. I'm going to review both. So, the present value of an annuity is the rent, or your monthly payment. So your monthly payment is $300. 1 minus 1 plus I was your interest rate divided by the number of payments per year. The interest rate is 8%, so it's 0.08, divided by, if you compound monthly, that means you're going to make 12 payments per year. Raised to the negative, n is 30 because you're going to make 30 payments in all over 0.08 divided by 12. Now, this is where this problem gets tricky. What I would do is, I would first in my calculator evaluate the numerator, get an answer. Take that answer and divide it by the denominator, putting that in parentheses. Then I would multiply by 300 to get the answer. In the calculator, we use that Tvm Solver. So if you press apps, number 1 should be finance. You press enter. Then number 1 should say Tvm Solver. So you press enter. N is the number of payments, so you'll put in 30. I% is your interest, not as a decimal. So you would just put in 8. It'll turn it into the decimal for you. PV is previous value, or in our case, that's going to be our present value of the annuity. So that's what we're going to find in a few moments. PMT, payment, that's $300 because you're making payments of $300 a piece. FV is your future value. Well, if you're paying into something, this is going to be 0, our future value. Sorry if this kind of got screwed up in the dialogue here because I had to pause for a second. The last thing, there are 2 things, but we only need to change one of them. PY is the only thing you need to change because CY will change with it. PY is payments per year. Well, if you're compounding monthly, then you're making 12 payments per year. It will automatically change this. Then you get your cursor back up here to PV, and you hit alpha, enter. That's your solve function. And it's going to give you a weird answer because it's going to say it's negative 8132.65. Don't worry that it says negative. We don't know why it does that. It turns out that the present value of the annuity is $8,132.65, which is the same answer you would get if you used this formula.